In this lesson, we're going to review factoring, especially and specifically when our lead coefficient is 1. So when you have your expression in standard form, which all of them on this page are in standard form, that means that you've got your ax squared plus bx plus c. You have it written in that way. When you're looking at the coefficient on the x squared, which should be your lead coefficient if it's written in standard form, that if that number is 1, then we factor it a specific way. And so all of these are written in that form, so we're going to review factoring when we've got that form of the equation. And hopefully you remember that we are, if we're looking at number 1, we're looking at, for factors of negative 21, we're looking for factors of the c that when you multiply them together, they add up to the b coefficient, which in this case is positive 4. So we're looking for numbers that multiply to negative 21 but add to positive 4. And so, of course, there are several factors of negative 21, but the ones that are going to make the most sense here are 7 and 3. So 7 times 3 will give you negative 21. Either of those can be negative, the 7 or the 3, to give you negative 21. It doesn't matter. But in order to have them add to positive 4, we need that 3 to be negative. So we end up with a 7 and a negative 3. We're going to take that first term, that x squared term, we're going to break those x's apart, and we're going to write this out in terms of two binomials. That first binomial, you're going to write in that positive 7, and that second binomial, you'll write in that negative 3. All right, and so this right here is your factored form of that expression. You could have those flipped. It could be x minus 3 times x plus 7. The important thing is that the x's are broken apart, that x squared is in, each of those x's is in two different binomials, and that you have your signs right. If we're looking at number 2, we're looking for factors of 5, so two numbers multiplied together that will give you 5, and we know right off the bat the only two numbers that multiply to 5 are 1 and 5, because 5 is prime. So the number itself and the number 1 multiply together to give you 5. We want the signs to be so that we get a positive 5 when we multiply them, but we want a negative 6 when we subtract them or combine them, add them. So if we make both of these numbers, both of these factors negative, when we multiply them together, a negative 1 and negative 5 will give us a positive 5. When we add them together, we will get a negative 6. So we're going to go over to the x squared. We're going to put one of those x's in the first binomial, the other x in the second, and then we're going to write in those factors. Negative 1, negative 5, it doesn't matter which order you put them in. Either way, it makes sense because we're multiplying these parentheses together. So according to the commutative property, we can switch those parentheses around. The signs are what is important there. Number 3, factors of 8 that add to 6. So here we have 1 and 8 we could use. We also have 2 and 4. All right, 1 and 8, you can quickly see that if you multiply 1 and 8 together, of course you'll get 8, but there's no way we can change signs on 8 and 1 to give us a positive 6, no matter how we combine them. But we can add a positive 2 and a positive 4 to get a positive 6. So these are the numbers we're going to pick, these two right here. I'm going to rewrite the x, breaking it up, putting 1 in each binomial, and then I'll put a positive 2 in one binomial and a positive 4 in the other. Okay, number 4, we're looking for factors of negative 6 that will add to a negative 1. So we've got 1 and 6 that work as factors. We also have 2 and 3. So we can see that if we want anything to add together to give us a 1 or a negative 1 in this case, we're going to have to use these two numbers here, the 2 and the 3. So if we need our one of them to be negative, one to be positive, because when we multiply them together, we want a negative 6. But we want them to add to give us a negative 1. So that means that's how we narrow it down. So now we know we need the 3 to be the negative. Make two binomials. Put in your positive 2 on one of them and the negative 3 on the other, making sure to break up that x squared one x term in each binomial. If we had gotten those signs wrong, then we would end up, if we had said positive 3 and negative 2, when we added them together, we would have ended up with a positive 1 in the middle. And so that's how you can double check yourself just to make sure that you've got those signs right. And 5, we're looking for a negative 12. When added together, give us a negative 1. So we could use factors of 1 and 12 are a possibility, 2 and 6 are a possibility, as well as 3 and 4. But once again, we can see that we need to add these two together to give us a negative 1. The only two that are close enough to do that are the 3 and the 4. And so since we need that 1 to be negative, we're going to have to make the bigger number, the negative 4, positive. The negative factor. I'm going to break it that x, write in the positive 3, and that negative 4. All right, number 6, we're looking for negative 8, that when added give us negative 2. Factors of 8 are those right there. We can see right here that the 4 and the 2 are going to be the factors that will allow us to combine to get a negative 2. All right, so we're going to, again, once again, we have to have the larger number be the negative because we want a negative 2 in the end. Negative 4 plus positive 2 will give us a negative 2. When you multiply these together, you get a negative 8. So break up the x value, put that plus 2 in one and that minus 4 in the other. Now, the whole point of doing the factoring is so that we can do problems like 19 through 21 down here, where they actually ask us to solve the equation. So these are different in that they're set equal to 0. Up above, those were just expressions. There was nothing to actually solve for because they didn't specifically tell you it was equal to 0. Down here, they're telling you they're making an equation that could be graphed that we could find the solutions for. So remember, on a quadratic, if you graph a quadratic equation, where that quadratic equation crosses the x-axis, those are your solutions. All right, so right here would be a solution on this picture and on the other side. So wherever it hits the graph on the x-axis, that's what you're looking for. Those are your solutions. So it's not always going to hit twice. It might only hit one time. If the vertex is on the x-axis, if it's actually sitting on the x-axis, you'll only have one solution. You could have no solutions if the graph isn't anywhere close to the x-axis. So what we're doing here then is we're going to actually solve for the specific places where it crosses the x-axis. So in number 19, you can't do it that in standard form. You have to put it into intercept form, which is that factored form that we just worked on at the top. So we're going to do the same thing here. We're looking for factors of negative 6 that add to a positive 1. All right, and so we have the option of 1 and 6, but I'm just going to kind of shortcut all this work and go ahead and just tell you we're going to use 3 and 2. All right, so if we use 3 and 2, we need it to be negative 6. So one of these has to be negative, but we want the coefficient on that x term to be positive 1. So that means that we need the 2 to be negative, so that when we add 3 and negative 2, we get a positive 1. All right, so I'm going to write those binomials out. And those binomials equal 0. Now, what we can do now, since we know that, is we can say, well, if x plus 3 times x minus 2 equals 0, one or both of those binomials could actually equal 0 as well. So we can set x plus 3 equal to 0. We can set x plus minus 2 equal to 0. And then if we solve, we can see that x equals negative 3 and x equals positive 2. So in my illustration over here, my not to scale illustration, but if we were looking at this, that would mean that this is x of negative 3 and this is x of 2 over here. Those are my solutions. It's where that graph is crossing that x-axis. Moving over to number 20, do the same thing again. We're multiplying to negative 10, adding to positive 3. So factors of, we could obviously use 1 and 10. We're going to use 2 and 5. Because when we multiply 2 and 5 together, we get 10. I need a positive 3 when they're added together, so I'm going to make that 2 negative. All right, I'm going to split the x's up. X minus 2, and then x plus 5 in that other binomial. All right, all of that equals 0 because we have an equation that says it is. So if the whole equation is equal to 0, either one of these binomials could be set equal to 0. Solve for x, and we get a solution of 2 and negative 5, which means it's going to cross the x-axis twice, once at negative 5, once at 2. All right, number 21, factors of 6 that add to this negative 5. So 3 and 2, 1 and 6 are also factors that we should check. So we need them both to be positive or both to be negative because the 6 is positive here. So the only two that are going to work are making these two right here negative. If we combine those two, then they will give us negative 5, and multiplied together they give us a positive 6. Right, again, this whole thing's equal to 0. So we end up with two solutions once again, one at x of 3 and one at x of 2. So the directions change on 31. Find the zeros of the function by rewriting the function in intercept form. So we've got a couple of things there that I want to make sure you understand the directions, because this is, if you can do what was above on the worksheet, you can do this. Finding the zeros of a function mean find x when the function, when the y value has a value of 0. So it literally means you're saying what is x when y is 0. Okay, so that's that first part of the directions. That's all it means to find the zeros of a function. But they're telling you how to do it. They're kind of walking you through it by saying rewrite the function in intercept form. They're trying to help you see that you can't find the zeros when it's in standard form. You need to put it in intercept form. They're just reminding you. So they're basically telling you, by telling you to rewrite the function in intercept form, they're telling you to factor it. So we're going to go through the same thing. We're going to find factors of 15 that add to that positive 8. So we've got 1 and 15 that we could use. We have 5 and 3 that we could possibly use. And so we can very quickly see that 5 and 3 is what we need, because we need to be able to combine in an adding form to get us 8. So we're going to split that x apart. We need them both to be positive. This is equal to 0. So if the whole thing is equal to 0, then we can break those binomials apart and set each of them equal to 0. And we will get x's of negative 5 and negative 3. So that's where this one would cross the line. These are the zeros of the function. When y is 0, the graph is going to be crossing the x-axis, and that happens at negative 5 and negative 3. All right, same thing on this one here. We're just setting y equal to 0. And then we're going to rewrite an intercept form, which means factor it. We're looking for factors of 32 that add to negative 12. All right, so we could do 8 and 4. There are a lot that are a possibility here. 2 and 16, 1 and 32. 8 and 4 are going to be the ones that we need. Those are the only ones that when we multiply them together, we can get a positive 32. If we make both of them negative, then we can add them together to get a negative 12. So we're going to have this right here. All right, we're going to set each of those equal to 0 so that we can solve, and we will end up with x-intercepts of 8 and 4. So that's where our graph will cross the line. That's where when y is 0, when the function is 0, it's going to be sitting on the line at 8 and 4. All right, and last one. Right, so factors of negative 35 that will add to negative 2. Again, there are several options for 35 as far as factors, but we're going to use 7 and 5. All right, 7 and 5, if I will multiply to negative 35 if one of them is negative. If this bigger one is negative, when I add them together, I'm going to get a negative 2, which is what I need. Pull them apart. Right, I'll set each of those equal to 0 again. And when I solve for x, I will end up with an x of 7 and negative 5. So those are my zeros of this function. All right, now in 40, we have a picture frame, and we are making a square frame of uniform width for a square picture that has side lengths of 2 feet. The total area of the frame is 5 square feet. What's the length of the sides of the frame? So there's a lot of stuff going on in this problem, but really the basic thing they're trying to get across to you with all these numbers and variables here on this diagram is that the measure of this picture frame going down the outside edge is it's a square, and it has the measures of x for the length and x for the width. Okay, so this is a square, and that is what they're wanting us to solve for. That's when they say, what is the length of the sides of the frame? They're asking you to solve for the x. Inside, we're going to be putting a picture, and the inside of the frame, it has these measures, this measure of 2 feet by 2 feet. So this inside here is also a square. All right, and so what they want us to do is or what they've told us, the other important piece is that the total area of the frame is 5 square feet. So that means that if we were just to know the area of this grayed out portion, just that grayed out portion would give us 5 square feet. It's not including the picture. It's just including the frame. That's the area that they've given us of 5 square feet. So if we take that whole square, the entire thing, the area of that, and we subtract out this piece that's cut out for the picture, we'll get that 5 square feet. We'll get the area of just the frame. So if we take our total area, pretending that piece was still in there, all right, and we subtracted from that inside picture area, I'm going to call it, just where the picture would actually show up, we would get the area of the frame. So the total area we don't know, but we do know that this is x, and we know this is x. So if we were to multiply those two together, that length times the width, we would get x squared. We don't know what it is. We don't have a value for it, but if x squared is an expression that would express that total area. Now, if we've got that square, that x squared, we're going to cut that picture area out of it so that you can actually place the picture in there and see it. So to find the area of that, we would take that measurement of 2 and this measurement of 2 here that they've given us and multiply those two together. So the area of that picture, inside picture area is 4, okay, 4 feet squared. I'm going to leave the labels off just for now. So I'm doing 2 times 2, and that's how I got that. So I'm going to take the whole thing, subtract 4 from it, and I should get 5 because they told us the area of that frame. So I'm just using this equation right here to fill in the numbers we know. Now, obviously we know we're going to need to factor in order to solve this problem. All right, so there are a couple ways we can do that, but sticking with the way this lesson is going, I'm going to show you how to do it by factoring, by putting this into intercept form. We can't put it into intercept form. We cannot factor it until this number over here equals 0. Okay, this has to be in standard form. And so right now this isn't in standard form because the 5 is over here. We need to pull that over to the other side by subtracting, and we'll end up with x squared minus 9 equals 0. Now it's in standard form. Even though the bx, that middle term is missing, it just means it's 0. It doesn't, but this is still in standard form. It's just standard form where b was 0, and so it zeroed out that middle term. Now we can factor this. So we're looking for let me rewrite over here. So we essentially have this, just so you can see it. that b was 0. Okay, so we are going back to our idea of factoring. We can take factors of -9 that add to 0. So factors of 9, 3 and 3. Of course, there's also 1 and 9, but we're going to use 3 and 3 because that's what's going to work for this problem. 3 and 3. If one of them's negative and one's positive, they multiply to -9. If one is negative and one is positive, they add to 0. So these are our factors. All right, we set both of those equal to 0 because the whole equation itself is set equal to 0. So we can set both binomials equal to 0. And we end up with an x of 3 and an x of -3. Now here's where you have to use your common sense and just take that positive value. We're solving for this right here, this x over here. What's the length of the side of the frame? You cannot have a negative length. So we just disregard that negative for this particular problem. We don't want the negative solution. We want that positive solution. And then just make sure that you add your label back on. So the length for that side is 3 feet.